In this video, we're going to use the reduction of order technique to solve a second-order linear homogeneous ODE with variable coefficients. For this technique, we need to already have one solution, y1, that was perhaps obtained via trial and error. We're then going to solve for y2 and the general solution using the 6 steps on the screen. Here we have a second-order linear homogeneous ODE with variable coefficients, as well as one solution, y1 equals 1 over x. So we can use the reduction of order technique. The first thing we're going to do is set the solution that we want to find, y2, equal to y, just so we don't have to keep writing y1 and y2 all the time, which is then going to be equal to some function u of x times y1. So we get y equals u of x times 1 over x. We're then going to take the first and second derivatives of y2 so that we can plug it into the ODE. Once we're finished cancelling and simplifying, we're going to be left with a second order ODE. So we reduce the order of the ODE by letting v equal to u prime, which then means that v prime equals u double prime. Subbing this in, we now have a first order ODE, and we know how to solve these. Because we have a first order linear ODE, we can use the integrating factor method to solve. And I'll put a link up now to the integrating factor method video. First, we need to find the integrating factor, I of x. Then we multiply it to both sides of the ODE, use the reverse product rule and integrate both sides so that we're left with v times our integrating factor equals the integral of the left-hand side multiplied by our integrating factor. Here we have x to the minus 3 over 2 times v equals some constant a. Solving for v, we have v equals a times x to the 3 over 2. Now that we know v, we can sub back in u prime equals v and integrate both sides to solve for u. Now we only need one solution, so we can choose values for our constants a and b as long as they don't make our x terms disappear because we don't want the trivial solution. So we can let a equal 5 over 2 and b equals 0 to simplify this solution so that we get u equals x to the 5 over 2. Now recall at the beginning we let y2 equal u times y1. Well, now we have both u and y1, so we can get y2 equals x to the 5 over 2 times 1 over x, and that just simplifies to x to the 3 over 2. Now that we have two solutions to the homogeneous ODE, we can write the general solution using the superposition principle, y equals c1 times y1 plus c2 times y2, for some constants c1 and c2. If you liked the video, then please give it a thumbs up. If you found it helpful, then feel free to subscribe. I make regular videos on calculus, linear algebra, statistics, psychology, and physics. As always, thanks for watching.